thanks for checking out the Poisson Distribution video from MathCelebrity.com. My name is Don Sepsic, founder of Math Celebrity. Today, you're going to learn how to figure out a Poisson problem and how to calculate the probability. So if that sounds good, let's go get it. So the Poisson distribution is a discrete statistical distribution. And you're probably asking yourself, Don, what does that even mean? Discrete means finite or countably infinite number of values. And the probability of a given number of events occurring in a fixed interval of time or space. Note the key word fixed. This is a dead giveaway for Poisson problems. Events occur with a constant rate. And the good part is each event is independent of the last event before it. And one more time, and I want to drill this in your head, Poisson means finite or countably infinite. So let's look at some distribution problem types. You'll see phrases or problems like the probability of a random number of accidents in a week. Or you'll see something like exactly X successes occur within a time interval. These are giveaways that you're dealing with a Poisson distribution. Let's look at the variables of Poisson distribution. That little symbol you're looking at is called lambda, and lambda is the mean. And what's nice is lambda is also the variance in the Poisson distribution. K is the number of successes occurrences. So in these problems, they'll say, hey, exactly 2 successes occur or at least 1. That is how you know you're dealing with K. So let's look at some Poisson distribution formulas. If you're not given lambda, and some of the time you are, you don't have to worry about this, but if you're not, lambda equals P times N. P is the probability of success, and N is the total number of trials. And here's the biggie for you. This is the distribution formula. So you're going to get a probability of K lambda. K, if you remember, is the number of successes in your time interval, and lambda is your mean and variance. Now, notice the exclamation point. If you've seen our factorial videos or you're familiar with factorials, then I don't need to explain anymore. If you're not, you read that denominator as K factorial. So let's read this out loud. Lambda to the power of K times E raised to the negative lambda divided by K factorial. Note E equals Euler's number, 2.71828. We've just rounded it to 5 decimal places, but that's Euler's number for those of you that are unfamiliar with E. Kurtosis, in case you got to drill deep into this distribution, is 1 divided by lambda. Let's look at an example problem. The number of calls coming per minute into a hotel's reservation center is a Poisson random variable with mean 3. Even if this problem didn't say Poisson random variable, notice we're dealing with a time interval at a constant rate. And the problem asks, find the probability that no calls come in a given 1 minute period. First, we have to compare time periods. So per minute and per minute, which is nice because that means we don't have to do any time period conversion. And before I go to the next slide, I want to send you another clue. No calls, which means K equals 0, no successes. We know that lambda equals 3, mean is 3. We want the probability K equals 0 or no calls. Let's continue. Lambda's 3, we want P, probability of K equals 0. If you recall, here's our Poisson probability distribution formula. The nice thing is we've got lambda and we've got K, so we can go plug and chug. We want probability of 0, 3, K lambda 0, 3. We plug and chug and we get 3 raised to the 0 times E raised to the negative 3 divided by 0 factorial. Well, what's nice is we've got 2 identities happening, which helps us simplify immediately. Anything raised to the 0 power is 1. So 3 to the 0 is 1. And 0 factorial, if you studied your factorials, is 1. So 1 over 1 cancels to 1, and we're just left with e raised to the negative 3, and you've solved your problem. Now, if it asks you to evaluate, you're going to have to take 2.71828 raised to the negative 3, but a lot of times they just want you to simplify and keep e in its simplest form. So there you have your answer. Now let's assume down the road that you don't have me working out every problem for you. How can you get help? Well, if you're on our website, you already know the Poisson calculator, and that's awesome. You can use that. But what if you're finding us for the first time from YouTube? Well, we've got a nice little solution for you. Go to mathcelebrity.com if you're on YouTube, and we'll probably have a link in the description straight to the calculator. But if you don't, just go to mathcelebrity.com and you type in either Poisson or Poisson Distribution. Let's go ahead and do that real quickly. So we'll jump over here. Here's mathcelebrity.com. Here's the search box. Let's just type in Poisson. Let's say you got a Poisson problem. You want to know how to solve it. You're going to enter your n, number of occurrences, and p. If you're given lambda, then I will show you in another video how to do that. But let's say you have n occurrences, probability of success is p. You want 2 occurrences. So in the problem we're given, they say exactly equal to, but sometimes they say no more than or less than, that's this button. And sometimes they say at least or more than, that's this button. But let's, for the moment, assume that we have exactly 2 successes. We're going to hit this button, x equal to k, which means exactly 2 successes. Because we were not given lambda, we're going to take p times n. 0.3 times 10, we get 3. We've got k, and what's nice is it's going to walk you through step by step, including evaluating Euler's constant to get to your probability. And for this particular problem, we get 0.224. So in the future, if you need help evaluating these, go ahead and use this calculator. I want to thank you for watching another math tutoring video. This is Don Subsick, and I will see you in the next video.